Class, what's up? Welcome to 1.7. We're going to solve, but now we're going to work with our pairs of angles, all right? So, as we've done the last couple of days now, we're still setting up the same exact equations, just we can plug some things in a little differently now, okay? So, complementary angles, we remember this, yes, we remember. Two angles whose sum has to be 90 degrees. Which is just great. Because now we know that if A is complementary to B, or excuse me, I should say angle A is complementary to angle B, well then I know that the measure of angle A plus the measure of angle B must equal 90 degrees. Okay? If I know the two angles are complementary, then they have to add to 90, so measure of one plus measure of the other has to equal 90. Same type of deals going on with supplementary. We still have our two angles. We know that this, however, is 180 degrees. And so really the only difference is when I write this equation, I now have measure of angle A plus measure of angle B equals 180 degrees. Okay? Okay. So those are complementary, supplementary. We also have vertical angles. We know that vertical angles are, and we're going to use the word congruent here, okay? This is kind of a new concept. Hopefully you guys understand that when I draw in two lines, well, the angles directly across from each other, whether it's left-right or up-down, right? Those angles are congruent to one another. All right, so now I know that the measure of angle A is equal to the measure of angle B. Okay, all right, I keep saying okay. I'm going to try to stop saying okay. Okay? Okay. All right. Oh, now I can't stop thinking about it. Here we go. Moving on. We're going to do some example problems. When we look at something like this picture, I'm seeing multiple lines intersecting. I'm seeing angles that are across from each other. Hopefully you guys just kind of see these are our vertical angles. Hints would be, again, intersecting lines. All right, vertical angles are formed by intersecting lines. Now, we don't have letters here. All right, we don't have letters. So on this one, what I'm going to do, I'm going to show you. You guys can always kind of just like add in some points to help you out. Like I can call this A, B, C, and I could call this like D and E. And that might help you write your equation. Because now I can see that I'm talking about this angle over here, ABC, measure of angle ABC. And I know it has to be exactly equal to the angle across from it, or DBE. So measure of DBE. And I know that because vertical angles are congruent. So I also should probably put in some little arc marks so I know that those angles are going to be congruent. All right, now, what can we do? We have our angle pair. We have our correct equation. Well, I know that the measure of ABC is 4x plus 2, so I'm going to substitute that in. I also know that DBE is 46. Oh, this is not bad. Okay, we just have an algebra equation here. So I'm going to have 4x equals 44, and then I'm going to have x equals 11. Now, if I go back and I read, identify, blah, 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 finally substitute, find the value of x. All right, find the value of x, I did it. All right, if you want, you can rewrite it over here, but I would not worry about it, okay? If you box your answer, I will be more than okay. Okay, cool. If you wanted to check, you could plug in 11. 4 times 11 is 44. 44 plus 2 is 46. They are the same. Beautiful. Okay, so this was an example of one where it didn't give you letters. You could create letters to help yourself write out the equation. I'm going to do a different example of that now on this next one, and hopefully it makes sense. Instead of putting in letters, guys, you can also kind of put in numbers. Like I can just say, when I'm looking at this, what's happening with these two angles? It looks like together they form a straight line. So not only they're a linear pair, but we know that linear pairs are two angles that kind of add up to 180. So we actually have supplementary here. We have supplementary angles. And so now what I'm kind of trying to get at here is I want to say something about this little angle and this big angle. I'm just going to call it like angle 1 and angle 2. Because now when I come over to my equation, I can write measure of angle 1 plus measure of angle 2, and that has to equal the 180 degrees. Sorry guys, that's a 1. All right. And once again, we have our equation. We know the angle pair. Everything's looking good. All we have to do is substitute. X minus 15 plus 4x equals 180. And I'll give you guys a little bit of time on that. Sorry, my hand was in the way. I think that's looking good. If I combine like terms, I get 5x minus 15 equals 180. Or I get 5x is equal to 195. Or I get x equals 39. And I believe that is good. Yeah. All right. Once again, if you want, you can write it on the solution line, or if you want to just write it x equals 39, I'm completely okay with either option as long as you show me. All right. Awesome. Last example. We're getting there. I have APE and EPQ are complementary. Okay, this is nice. It's giving us angles. We can draw this picture. It's going to be a little easier, I'd say. Complementary angles don't always have to be adjacent, but when I'm drawing these angles, APE, EPQ, hopefully you guys agree with me and notice that P is the vertex of both of these angles, which means these angles actually do have to be connected. All right, so I'm going to draw maybe A, P, E, and then I have E, P, Q. All right. Now this picture is missing one thing for sure, actually a couple things. We could label if we wanted. This didn't label it for us, so we could do 3x minus 8 and x plus 2, which is nice. But one other thing that I want you guys to get in the habit of looking for is if you see complementary, you know that's 90, or in this case, I care that it's going to be a right angle. All right? So now, equation time. My equation. Remember that because these are complementary angles, we could go back. Complementary angles have to add to 90, or we're going to have an equation such as measure of angle 1 plus measure of angle 2 is going to equal 90. So we want to try to replicate that over here. And that would be very easily something like measure of APE, because that's one of my angles, plus measure of EPQ, so measure of angle EPQ, and that just has to equal 90. All right, now we plug in, and we kind of do the same stuff that we've been doing. So 3x minus 8 plus x plus 2. I should put that in parentheses, my bad. Equals 90. All right, well, when we try to clean this up, we have 3x and 1x, so that's 4x. And we have negative 8 and positive 2, so negative 6. And I have 4x is equal to 96. And what's that? 15 plus 21? No, that's wrong. 24, sorry. 24? Yeah, 24. X equals 24. All right. Now, that gets us our x value. Please make sure, though, in this case, it wanted us to find the measure of both angles. So, we're going to have a little bit more work to do. Maybe come down here, say measure of APE. Well, I knew it was going to be 3 times x, or 24, minus 8. And well, that's 72 minus 8, So what's that, 64? Measure of EPQ should be x plus 2, or 24 plus 2, which is 26. And oh my gosh, what do you know? 64 plus 26 is 90, which is a good check because we knew that both of our angles needed to add to 90 degrees. All right, so this was a good little mini intro lesson on solving with pairs of angles. And by pairs, we mean complementary, supplementary, and vertical angles. Please make sure that you, if you need to, if you didn't quite get it, maybe try to watch parts of the video again, or just jot down some questions so that you can ask me in class tomorrow. I hope you have a great day. I will see you later. Peace out.